In this video, we are going to remind ourselves of how to work with composition of functions. So remember, this is when you take one function and you substitute it into the other function everywhere there's an x. So we're going to start with f of g of x. Not really a fan of this fog notation. Another way to take a look at this is f of g of x. I think this makes a lot more sense because you can see that the g of x here is going in for x into the f function. So that's exactly what we're going to do. One way to do this and to keep it a little bit more straight in your mind is to simply replace g of x with 3x. And then again, you can see you're taking that 3x, everything in parentheses, and replacing the x, just the x, in the f function with 3x. So simplifying, we get 9x squared minus 1. Again, for the domain, we have to look at both the g of x function and the composition f of x. G of x domain was all real numbers, f of x quadratic, so that domain is all real numbers as well. So we have no domain restrictions on that one. Next, we're going to do it the other way. We're going to take the f function and put it into the g function. So replacing the x, just the x, in the g function with x squared minus 1. Simplifying, we distribute our 3. And for the domain of the f function is all real numbers, as well as our composition. So far, easy domains. Let's take a look at some where we're going to have a domain restriction here. So we're going to start again with g of f of x. Again, this notation, if you want to, and I'm writing it backwards, if you want to change it to the notation that makes a little bit more sense and it's a little bit more straightforward what exactly you're doing. So I'm going to rewrite the f of x with the square root of x plus 1, and I'm going to take that entire term, replacing both x's in the g function, give myself a little more room to work here, with that. Alright, so our first term, the square root and the square cancel, leaving us with x plus 1. And of course we cannot distribute that 2 under the radical because the 2 is not under the radical to begin with. So this is our function. For the domain, when we think about our f function, what's under the radical must be greater than or equal to 0. And if you look at our composition, we've got the same thing under the radical. So the domain in this case, that x plus 1 has to be non-negative or greater than or equal to 0. So when we solve for x, it's got to be greater than or equal to -1. That's our domain. Last example here, now we're going to take the functions and reverse them. So replacing our g of x with x squared plus 2x. Simplifying, substituting that into the f function for x, the x squared plus 2x goes under the radical with our plus 1. Now this, what's under the radical, factors, so I'm going to do that. What multiplies to 1 and adds to 2 would be 1 and 1. So it ends up being x plus 1 squared. And again, the square root and the square cancel, so our composition is x plus 1. Now what would be nice is if we could say the domain was all real numbers, but it started under the radical. Now here's where it gets really complicated. Under the radical, we have a parabola. Where is the parabola greater than or equal to 0? Well, if you think about what a parabola looks like, we could have multiple places where the parabola is greater than or equal to 0. They will always start at the zeros of the function. So to find the zeros of the parabola, we would factor, which we already did. And in this case, what's nice about this parabola is there's only one 0. We know that it opens up because our x squared term is positive. So our parabola actually looks like this. and the 0 would be at -1. And our parabola would actually touch the x-axis. But because it opens up and our vertex is on the x-axis, our parabola is positive everywhere. So our domain actually is all real numbers, because once you substitute those values, you're going to get a positive or a non-negative answer for your parabola before you take the square root of it. So it ends up working out for us for our domain. Now, one more thing that I want to say is if we look at our g of x function, that domain was all real numbers. We did not have to look at the f of x function separately. That one did have a domain restriction because it was under a radical. But because we started with the g of x function and put it into the f of x, we then made the whole thing positive under the radical. So there are no domain restrictions on this one. And your U-try questions.